Today I'd like to share with you a couple of very important discoveries that I've recently made. I've been racking my brain for the last few weeks trying to figure out how to extract the amplified high voltage from this toroid without the use of brushes or a commutator or friction of any kind. Just some simple electronics, not anything complex. Well, I'm going to show you that I have done that, and it's over 550 volts continuous. That is pretty incredible. The secondary thing that I'm going to also show you is how to double the output from the pulse motor side of your Q3. If you already have a Q3, or if you're thinking about getting a kit and building one, you're going to want to see these two things. These are both pretty incredible. Okay, so the first thing we'll show you is what we've got going on right now. This meter isn't connected to anything. I do want to show you, let's see if I can zoom in on this, that right now each one of those little marks above zero is 120 milliamps. I've used this meter, I keep it on this machine all the time. So we're pulling maybe 150, 160 milliamps, somewhere around that. And, whoops, sorry. And here, this is the meter that comes off of my MPPT charge controller, and it's 27 standing volts, and it's pulling 0 amps right now, because what it does is this thing will run off the caps. The generator will run, it'll charge batteries, it'll do high voltage experiments, it'll do all kinds of stuff off of just whatever is in these caps, and when the threshold of capacity drops just a little bit, bam, the charge controller fires, and now it's fired, and it's 1.3 amps, boom, just for a couple seconds, then back to zero. It's probably the best conservation of input that I think I've ever developed, and so it's a pretty cool thing that it does. Right now, what we're going to show you is we're going to show you the amplified output from the toroid. So what I'm going to do is I'm just going to take this and connect it here. And there you go, 560 volts, 559, pretty respectable. You definitely don't want to get shocked from this like I have. These last 2 days, this right hand was shocked so bad that I swear I could only close it about this much for about 2 hours. It's a lot of, I guess there's some amperage in there too. I don't know how much, probably not a whole lot, but it's more than just 550 volts and 10 milliamps, because you know, this is a 16 gauge wire. This isn't hairline fine wire that you'd find on you know, a small Tesla coil or something of that nature. The negative side of the meter probe is connected all the way over here, because that way I'm staying a far enough distance apart so that I don't shock myself again. It's bad. It's really strong. But anyway, so there you go. That's the output on that. Now you don't have to use that. You can just run with the generator, and you can take the output off the pulse motor side. I've explained this before. You've got 6 pulses going in. You got 6 pulses coming out from inductance. So you got 12 pulses per revolution on the pulse motor side. Then with the new Q3 setup, this alternator that rectifies this generator gives you 6 more pulses. So there's 18 pulses. This one's 20 degrees out of phase. The voltage is varied from the voltage, the input and the output pulsing of this are different. The 20 degrees out of phase is different. So you got all these varying voltages and frequencies going on to charge batteries, and it really excites the chemistry of lead acid batteries and charges them in a super efficient way. And for renewables, this is just it's really a key thing to have. So again, you know, you can see it's still pulling 0 amps, just the standing voltage 27, because these caps are set up in 3 separate banks of 27 volts each, but they're connected, and so they work simultaneously. Okay, next thing we want to show you, or I want to show you, is let me give you a whole view here. I'm going to take this off. Now, this is nothing but a ground wire, an earth ground. And I've got a ground wire on my solar setup. I only have one panel, and it goes through the MPPT charge controller and into 4 deep cycle batteries, and it keeps them charged up and topped off all the time. Now, for that system, let me zoom in just a little bit more. I have an 8-foot steel, copper-plated steel ground rod. It's a standard ground rod. 8 feet in the ground, just sticks a couple inches out of the ground, and then next to it, I have another ground that is now going to the generator itself. Now that is an old piece of water pipe. It's galvanized steel, and it's obviously hollow, so it has a little bit more surface area, but copper and zinc basically. But they're about 12 to 14 inches apart from each other in a north and south relationship, with the copper being north of the galvanized steel pipe. Then I've got it connected with this, I think it's 6-gauge standard solid, copper ground wire. Then it comes into some flexible wires terminating in, like this one here. This one, this one is going to the galvanized pipe. This one's for the generator, and the other one is coming off of my MPPT. Wow, it's still at 0. It's such amazing conservation. Okay, back to the subject at hand. Let me set this on here and set the ground wire down for a moment. And let's change to measure. Oops. Let's get this negative here into here. Okay, now there we have, whoops, keep that light off, glare, 16, a little over 16 volts coming out. All right, and the reason for that is, number one, again, we're pulling very little power. This is running at about 460 RPM. Let's throw the tach on it and just check. 471 RPM. Okay, and that's about the slowest I can make this machine run. Any slower and it just won't pulse. The reed switch won't be in close enough proximity to pulsing. So anyway, so that's the speed. And so now this is just from the pulse motor side itself, 16.26 volts. Okay, so if we wanted to double that power, we should be talking about 32, 33 volts, right? Okay, so all it takes is one wire, and this is it. It's an earth ground, and watch what the voltage does when I connect it. Wow, it's more than 32, it's more than 33, it's almost 35. And this is actual pulsing power that will more quickly charge your batteries than it would before if you speeded it up and you were running maybe 400 milliamps, 500 milliamps of current at the 26, 27 volts that this system operates on. This will just double that speed, and that doesn't even include the output coming from this generator side or the toroid. Now, you don't have to use the high voltage from the toroid. You can use the standard voltage. It's low. It's between 8 and 12 volts typically coming off that. So to drive that from 8 to 12 volts up to 560 volts is just it's astonishing. And I'm not really sure exactly how it's doing it, but I know that it took me a long time to come up with a circuit that was simple enough. I'm going to zoom out. Sorry. That was simple enough to do it and maintain it. Again, let's look at this one more time. I'm going to pull the ground off and see it just drops back to the 16, 20, 25 and put it back on, and it's back up to nearly 35. So it's just incredible with one stinking earth ground. Now, is it the combination of the copper and the zinc? Is that doing something? Is it the double ground? I know people say Oh yeah, that's what it is. It's the power coming in off your MPPT charge controller. And so, you know, that's what must be doing it. Well, whoops, nice tripod movement there. Okay, so let's go back in. All right, it's still a 0. Let's turn this thing off totally. Okay, takes a few seconds and it's off. Okay, now there's 0 volts, 0 amps coming in to these 2 wires of input from the MPPT auxiliary output port. All right, well, if that isn't good enough, let's just unplug. Let's just take the positive off there. We'll leave the ground, and we're still at 0. We're totally unplugged there, and we still have, with it off, 15. It's a little lower, because right now we're just running on caps. There's no input whatsoever. Just the caps. The caps are running the system. You could be charging up batteries, and we do this for a long time too. And you can be charging the batteries and still do your high voltage experiments with a toroid. And I've only tapped 1 channel off this thing. Well, I call it a channel. It's a signal or something. It makes a funny little clicking sound when it engages, and it gives you the high voltage. Okay, real quickly, let's see if you can hear the sound. I've got the camera in pretty close, and all I have to do is connect this right here. But it's that that kind of clicking signal sound that it makes in the toroid. It's not bearings, it's not loose wires, it's nothing rattling. It's just actually a frequency sound. Hear it? It's off, on. I don't know if the microphone's sensitive enough to pick that up, but we'll give it a try. So when you hear that little clicking sound, you know that it's cranking out about 560 volts. Anyway, I was attempting to do a secondary one. I thought, well, maybe we can get 1100 volts out of it. And I think I might be able to do that, but after I shocked myself a second time, I thought, well, I don't even know if I want to show this to anybody because I don't want the liability. Well, there is no liability. This is all experimental. If you want to do it, you can do it, and you can do it. It's not hard at all. All right, so let's just hook this back up, and there we go. We're back up to 34 volts from whatever it was, 15. Yeah, 15, low 15. Oops, that doesn't help. There. So it will do it, and we're not plugged in, and we're at 0, 0, 0. Yeah. Okay, to wrap this up, I titled the video 559 volts out with no electric in, and it's absolutely true. There's no electric coming into this. It's nothing but a spinning permanent magnetic rotor. It's generating its own electricity. It's not a transformer. It's not a rotary transformer. It's not a transducer, though it may have some transducer characteristics. It's not a metadyne. It's not an amplidyne. I don't know what the heck it is. It's a quantidyne. It's a Tesladyne. I don't know. The only thing similar to it is what Tesla was doing with his dynamos in the late 1800s. It's interesting, but he did not have the advantage of the circuitry components that we have today, or he probably would have done this only on a greater level, which I totally intend to do. I'm not stopping here. If you're interested in a Q3 experimental generator kit, check us out at quantummagnetics.com. We try to keep a few of these in stock. You won't find anything like this available anywhere else. So thanks for watching, and see you next time.